both of these problems here give us situations where we know how much either something costs or how much we need for a certain amount of something, but then we're changing the amount that we're dealing with. So we're going to use proportions to help us solve both of these problems. So in this first one here, we know that 10 gallons of gas costs $26.19. At the same price, we want to know how much 16 gallons would cost. Before we start this, let's just get an idea of what our answer should be. If 10 gallons cost $26, then what do I know about 16 gallons? Is it going to be, let's just keep it simple, is it going to be more than 26 or less than $26? More. It's got to be more, right? So we're buying more gas, we should get an answer that's bigger than $26. Would it make sense to get an answer like $100? No. If we get an answer like $100, that means that we're spending 4 times what we have here, so that would be like close to 40 gallons of gas. We're only getting 16. So we should get something that's more than 26, but not a lot more. Kind of in the same ballpark as the 26. All right, so the first thing we're going to do is we're going to write a what? Ratio of units. So we're going to write a ratio of units. And what we have going on here is we have 2 different units that we're comparing to each other. So we're going to write a ratio so that we make sure we keep those units straight throughout the problem. In this problem here, what are the 2 units that we're using? Gallons. Okay, so we have gallons of gas, and we have the cost of the gas, which actually the units aren't cost. Okay, cost is going to be the number, but what are the actual units on that number? No. We can't buy something, or something doesn't cost a certain number of gallons. Something costs a number of dollars, right? So the units here are actually dollars. It would not be a terrible thing if you put cost as your units, but it's not really cost that is your units. It's the dollars, and that tells us how much something costs. So the 2 units we're going to use are going to be gallons of gas. So I'll just put gallons. And we're going to put the cost on the bottom, and I'm just going to put dollars down there. All right. It would be okay, and you would get the right answer as long as you keep everything straight if you put the cost on top and the gallons of gas on the bottom. Okay, you can flip that. You just need to make sure then that everything you do, you have the cost on top and the gallons on the bottom. All right, for us, we're going to put gallons on top and the cost on the bottom. So next thing we do is we write a ratio, and the first ratio we write is going to have 2 quantities that we know go together. All right, so we're going to have a number of gallons and we're going to have a cost that go together. In this problem, what 2 quantities go together? The 10 and 26.19, right? So we know this 10 gallons here goes with the $26.19 here. And which one of those 2 should go on top, the 10 or the 26.19? 10. Why the 10? Yeah, we said in our ratio of units, gallons are going to go on top, so we're going to put gallons on top. That's going to be the 10. On the bottom, we're going to have 26.19. All right, and I don't need to put the dollar sign on here. I know that it's dollars because it's on the bottom, and our ratio of units here says that that's going to be in dollars. So all we really need to deal with is the numbers because we know what the units are from this here. All right, the other ratio is going to have something that we need to figure out. It also has something that we know, but it's going to have something we need also. What is the one piece of information we do have about what we're looking for?
16.
The 16 gallons, right? So we've got the 16 gallons right here. And this 16 gallons is going to go where in this ratio? Top or bottom? It's going to go on top. And we know it goes on top because gallons go on top. All right, again, if you flip this ratio of units and you had dollars on top and gallons on the bottom, then the 16 would go on the bottom. All right? So the piece of information we need that we're looking for then, and it actually asks for it in the question, how much would it cost? So we're looking for the cost, and that's going to be in dollars. So what do you think we should put here? A variable. I like C. C is representing how much it's going to cost. And then to complete this proportion, we have 2 ratios, so what are we going to do with those 2 ratios? Don't say cross multiply yet. What?
Equals
Yeah, we're going to put an equal sign between them. So it's not a proportion until we say those ratios are equal to each other. So we're going to put an equal sign between them. Now that we have a proportion, what can we do to solve it? Cross multiply, yes. All right, so now we're going to solve. Cross multiply, 10 times c is 10c. And 16 times 26.19 is 0.04. Okay. Then we solve, right? At this point, it's a one-step equation. We've been doing those since August, I think. So I hope we are able to do that. We want to circle the variable, draw the line of equality, and then how do I get that c by itself? Divide by 10 on both sides. Dividing by 10, there's actually a trick to it. Anybody know the trick? When we divide by 100, we move the decimal 2 places to the left, right? If we divide by 10, what do we do with the decimal? Just move it 1 place to the left. So when we divide it by 100, 100 has 2 zeros on it, so we move the decimal 2 places. 10 has 1 zero at the end, so we can move the decimal 1 place to the left. And we end up with 41.904. And even if you didn't know that trick, you could use the calculator, right? All right, are we done? No, we need units, right? So what are the units on this? Is this $41.904 or is it 41.904 gallons? It is. It's dollars, right? So C, the cost, is on the bottom, and that's in dollars. All right, so we look at our ratio of units to remember that. And so I need a dollar sign on here. But then with the dollar sign on there, I see another problem with our answer. What's the other problem with our answer? Well, not reduce, but we're going to have to round it, right? Since we're talking about money here, since we're talking about dollars, we don't want this thousandths place here. All right, the gas station isn't asking for thousandths of a dollar. They're just asking for hundredths of a dollar because that's cents, right? So I want to round this to the hundredths place, which is going to be that 0, and I have to get rid of the 4. When I get rid of the 4, what's going to happen with the 0? It stays the same. It's less than 5, so that's going to stay the same. So I'm going to just clean up my answer here, rewrite it. C is equal to $41.90. In the second problem here, looks like we're baking some cookies. So the recipe that we have for baking cookies says that we need 2 cups of chocolate chips for 60 cookies. Okay, this is actually the recipe that you would use if you're making the Nestle Toll House cookies. So we want to make, we have five cups of chocolate chips, and we want to make as many cookies as we can. So we want to know how many cookies we can make with 5 cups. Before we get started, should we be able to make more than 60 cookies or less than 60 cookies? More, right? So if we have 2 cups of chocolate chips, we can make 60. If we have more chocolate chips, then we can make more cookies. All right, so just like we did in the last problem, we kind of figured out what the answer should be. We said it should be bigger than 26. It ended up bigger than 26, right? This one, we want to do the same. So we know we should be able to make more than 60 cookies. All right, and we'll start this problem then by writing our ratio of units. What are the 2 units that we're using here? Cups and cookies, right? So the cups are measuring how many chocolate chips we have. So we have cups. Really, it's cups of chocolate chips, but you don't need to write that. And number of cookies. Or you could just write cookies. Again, if you flip your ratio of units, then everything you do on your paper is going to be flipped from what I have up here. You'll still get the same answer, though. All right, we need 2 ratios now. One with 2 quantities that we know go together. What 2 quantities in this problem go together? Cups of chocolate chips and number of cookies. 2 cups is going to go with the 60 cookies. Which one goes on top? 2, okay. So we put 2 on top. That's 2 cups of chocolate chips over 60 cookies. Then we write another ratio, one that's going to involve something we need to find out, which the question's asking how many cookies can we make with 5 cups of chocolate chips. So where's that 5 going to go? Is that going to go on top, or is that going to go on the bottom?
On top.
It's going to go on top. Remember, ratio of units, we have cups of chocolate chips on top, number of cookies on the bottom. That 5 is the number of cups of chocolate chips that we have, so that goes on top. And then what we're trying to find, the question asks right here, how many cookies can we make? So that's going to be our variable. What variable you want to use?
C.
C would make sense here again, wouldn't it? So we'll put C there. This time C represents the number of cookies. And what do I need to do so that I can solve something here?
Equal sign.
Yeah, put an equal sign, make these ratios equal to each other so that we have a proportion. And then to solve that proportion, we're going to cross multiply. 2 times C is?
2C.
2C. 60 times 5 is?
300.
Circle your variable, draw your line of equality, and how do we solve that?
Get rid of the 2.
Get rid of the 2 by dividing by 2 on each side. 2's cancel, leaves C equals
150.
150. And we're not quite done, right? Just like all of these word problems we're going to do, we need to put units on our answer. What is this, 150 chocolate chips? Or 150 cups of chocolate chips? That's a lot of chocolate chips, isn't it? It's 150 cookies, right? Remember, C was on the bottom. That was representing the number of cookies. So our units on our answer here should be 150 cookies.